Okay, so we'll pick it up there with number 13. Okay, so piecewise functions. So definitely one of these on the exam next Wednesday, Thursday. So how do you do piecewise functions? So you do them in pieces. So the put a little graph over here, and we're looking at, notice -3, +1, +1, +1. So the walls of separation are at -3. So this is -3 here. Now, again, this dotted line is not really an asymptote line. It's not really even supposed to be there at all. I'm just putting it on there to help you see what's going on. So there, I'm going to put a wall at -3 and a wall at +1. Just to show you, this thing's going to be in 3 sections, huh? This graph is going to be in 3 sections. It's going to be, well, actually, it's going to stop. It's going to go from -3 to +1. Oh, really just 2 sections, huh? It's just not, I guess I'll put the -3 on there. It's just not going to go left of -3. It'll stop at negative. There'll be nothing over here. Does everybody see that? See what that's saying right there? Can you read that? Are you getting better reading these math things? It's saying x values between -3 and 1. Right? So it's not going left of -3. So, in other words, this function here is going to be in this section. 2x plus 7 is in this section between -3 and 1. Right? And right on 1, this is right on the line, x equals 1. It's just going to be 8. Period. Let's just do that right now. That means there's just a dot up at 8. Doesn't even depend on x, right? So 1, 2, 3, 4, 5, 6, 7, 8, right there. That's over 1 up 8. That's what it says. When x is 1, f, or y, is 8. Huh. So that makes it remember f is y, all right? So, and then when you're to the right of 1, over here, to the right of 1, you're going to do the function -2x plus 6 in that territory. Does that make sense how the piecewise thing works? Different functions in different sections, right? So over here, when x is between -3 and 1, you're going to do the 2x plus 7 function. And to the right of 1, you're going to do the -2x plus 6. And then just plug in to those functions for dots in those regions. That's basically it. I mean, that's all that really is going on with piecewise. You just find out, what regions the different functions exist. Yeah, see, now this one's off today, huh? It's off, the projector's like, whereas that one's good. And it was just on yesterday. Anyway, sorry, my little table. It's like every day it moves a little bit. All right, anyway. So, so then we just plug in. Now, you do want to check the wall, right? So when you make your dots, I just need, these are both just linear equations, aren't they? They're just x to the first power. So they're both, right? This is x to the first power, this is x to the first power. My point is they're both going to just be straight lines. No curvature. No U-shapes or anything like that, right? They're both just straight lines. So I just need 2 dots. It's always best to check the walls themselves. So for the first one, I'll just do an xy table. And I'm doing the y is 2x plus 7 one. And I'm going to plug in x is -3 and x is +1. Since I only need 2 dots, and those are the 2 walls anyway. So -3 and +1. You could plug in other things. You could put in -2, -1, 0, and find out where it is, but you don't need to do that extra work. You only need 2 dots, and you might as well check the walls, because you need to see where it connects up or doesn't connect. Anyway, now, I'm going to circle the 1. Why am I circling the 1? It doesn't really hit it, right? Remember up here it says x is less than 1, not equal to 1. So I'm circling, that's my little way of reminding myself it's going to be an open dot there. But you still need to do it, right? Don't stop at 0. That's the mistake I've seen a lot of students make over the years. Don't stop at 0. Because, well, it doesn't hit 1, I'll stop at 0. Don't think whole number-ish, right? It's a whole bunch of numbers between 0 and 1, even 0.99999. So it gets infinitesimally close to 1. You need to basically check 1 with an open dot. All right, plug that in. 2 times -3 plus 7, what's that, +1? And 2 times 1 plus 7, that's 9. So that means back 3, up 1, solid dot here. Is that 1? No, I went a little high, but whatever. Over 1, up 9, that'd be way up here. Whoop, or here. Open dot there. I'm messing everything up here. Here, let me erase this. This is a little high. Okay, so it should be, there we go. There's back 3, up 1, which is this one. And then over 1, this is over 1 up 9, open dot, connect them. Is that good? I connected them, solid dot to open dot at over 1 up 9. And then there's this dot here. Where'd you do that? Which is at over 1 up 8, because they told me when x is 1, y is 8. Right? Solid dot right there. And then to the right of 1, over here I'll make an xy table when I'm going right of 1. So that'd be 1, I circle it, and say like 2, or whatever else, some other number, it doesn't matter. I'll just do 2. You can do 3, 4, 5, 6, whatever. You just need 2 dots to the right of 1. You good? I'm making sense? So I'm plugging in 1. I'm plugging into what function? 2x plus 6. So what's that going to be? I'm running out of room here, huh? So I should have scooted it over here. Let me scoot it. So 2x plus 6. So we got x, y equals 2x plus 6. I'm plugging in 1 and 2, 1 circled. So 2 times 1 plus 6. Can't even see it on this screen anyway. Huh? You're going to have to look over there. Is that 8? Is it negative 2x? Oh, thanks. I couldn't even see that negative sign. Thank you. Negative. Negative. So that's what? 4? That should be 4. And then negative 2 times 2. Well, I'm just totally out of room. Negative 2 times 2 plus 6 would equal 2. So over 2 up 2, solid dot. And the other dot's at over 1 up 4, which is right there. There's over 1 up 4, over 2 up 2. And it goes, I'm going to put an arrow on that side. Everybody see what happened then? So to the right of 1, I made the little table, right? And I plugged into negative 2x plus 4. So that's getting pretty, negative 2x plus 6, negative 2x plus 6. And I got over 1 up 4, open dot, and over 2 up 2, solid dot, and it's an arrow. That one goes to the right forever because it said greater than 1. So it goes forever to the right. Whereas the one on the left stops solid dot right there at negative 3. So there's the graph in 3 little pieces, huh? And none of them connect up. That's more typical. Normally they don't, connect. Is that okay? We good with that? Questions I can answer on that? So piecewise graphs are just that. They're graphs in different pieces. Let me ask you, how would you find the domain and the range? Let's just do domain and range on this one, just to make sure. Because first I would ask the domain. I would do the graph first. I wouldn't do anything until even though their first question is domain, and their last question or their third question is graph, just do the graph first. Do the graph first. The old saying, picture worth 1,000 words. Picture's worth 1,000 questions. It'll answer all your questions. So do the graph first, and then the questions will be easy. So now that we have the picture we're looking at, what is the domain? Remember what domain is? Domain, when you're looking at a graph, is the width, the left, right. Left edge, right edge, huh? Domain is left edge, right edge. So what's the left edge of that graph? Yeah, write it down here. Yeah, domain's negative 3, solid bar, right? Because it hits it solid. Solid dot right here. And then the right edge? Infinity, with a parenthesis always. Right? Obvious. Just look at the graph. Right? So the graph answers all the questions, right? What's the range? Because I will ask you the range as well. Remember the range? That's the vertical span. So let me put it here if I can. Range. Range is the bottom comma the top. How low does that? What's the lowest point that graph goes? Yeah, this arrow is going down forever. So negative infinity is the bottom. What's the top of the graph? Oh yeah, almost hits 9, but open dot there, right? So negative infinity to 9, parenthesis at the 9, not a bracket because it doesn't hit the 9 right on. The top is an open dot up there, huh? Make sense? Easy when they get the picture, huh? Picture answers everything. So just do the picture and then answer the questions. And the other one, what, intercepts? That's easy. You can see the intercepts, right? Well, maybe it's not that easy. Looks like maybe we better do that. Okay, let me... oh, but I don't want to lose the graph. Oh, here, I can take a picture of this, can't I? Okay, let me go to a new screen and see if I can do this thing here. Okay, there we go. So I'm on a new screen. So, oops, I'm scribbling over it all the worse. So let's take this thing I'm going to erase. Oh, no, that doesn't erase because, okay, I'm confused. All right. Yeah. I don't want to waste too much time, which is what I always do. Can you see the intercepts on there? Can you see them? Here, let me go to a new screen. Maybe you guys can help me out here. Let me see. Let me paste the original. So there's the original again, before I made a big sloppy mess out of it. So let me see. It was back here at -3, wasn't it? And where did it hit? -3, 2? Was it 2? 1? 1. It was 1, huh? And then it went up to like 3, 4, 5, 6, 7, 8, 9. It went up to like 9, right? Didn't do that. And then it was the solid dot at 8. And then it was, so that one's at 8. Oh, that's the intercept there, obviously, huh? And then it went, what did it do? Oh, 1, not 0. Oh, you're right. I'm getting confused. So it was over 1, not 0, yeah. So this is 1, 2, 3, 4, 5, 6, 7. This is 8. This is 9. It was here and here, huh? Like that, and then that was over 1 over 2. And then where'd it go from there? 2, 2, huh? Like that. And then over 1 up 4 at an open dot. Like that? I got it right? Okay. So there it is. A little cleaner now. Now, what are the intercepts? Looking at the graph, what are the intercepts? Well, one of them looks like right there. It's hard. I think that's it up 8. But how could I be sure? Remember how you find intercepts? How do you find that's a... Yeah, it might be. I'm not sure. How do you find it? Yeah, plug in 0 for the x. Because whatever this point is here, it's over 0 up something, isn't it? Whatever it is. So plug into what? To what function? Well, to the one that's generating this piece of line. Who's generating this piece of line? The 2x plus 7. So take y equals 2x plus 7 and plug in 0 for x. Oh, yeah, you're right, Robert. It's 7, not 8, even though my graph looks like 8. It's really here. I'm just drawing badly. It really goes through this spot. So it's at 7. So there's that intercept, right? Over 0 up 7. So see how you find it? You just grab the piece of equation that goes through it and plug in either x is 0 or y is 0. Because intercepts always have one of the letters 0, huh? How about this is an intercept here, right? That's another one right there. How do we find that one? Well, that one we plug into the minus 2x plus 6. That's some point where y is 0, isn't it? So y equals negative 2x plus 6. Let me bring it down here. You take the equation y equals negative 2x plus 6 and you make y 0. And then you solve. So subtract 6. Divided by negative 2. So x is 3. So that's 3, 0. Good? We all good? 5. So that's everything they asked for. All right. All right. 17. All right. So there we go. We got. They're basically going to have us. They're having us work these backwards. So they've been giving us the equations, and we make the graph in pieces. Now they're having us go backwards. They're giving us the graph in pieces. Work back to the equation. So that's a little trickier to go backwards. So let's take this piece first. We'll do them one at a time. Let's find the equation for that piece. Oh, by the way, where's the, maybe even before that, we should find out the wall. Here's the wall of separation right there, huh? Where's that wall? X is 0, huh? So this is 0 and that is 0. That's the wall. Tracking with me? See how I know that's 0? Right? Because this first function is between negative 4 and 0, right? Negative 4 and 0. The other one's 0 and beyond. This one's 0 and beyond. This one's from negative 4 to 0. Isn't it? See that? So first off, find the wall. Let me get rid of that kind of stuff. Get that mess out of the way. All right, so we got that. Now I've got to find the equation and find the other equation. So let's start with the top one. The top one is the left one. It's this one because it's between negative 4 and 0. Right? Between negative 4 and 0. So what's the equation of that little piece of line there? How do you find the equation of a line? Y equals mx plus b. It's just a line. It's not curved. They're not going to make you do U-shapes backwards or anything. They're just going to give you straight lines. So it's y equals mx plus b. So how do you find, so got to find the m, got to find the b. Can you tell the m by looking at it? Can you tell what the slope is? Yeah, remember slope is rise over run, huh? Rise over run. That's what m is. So rise, run. It goes up 2, doesn't it? And over 2, I think. So the slope is 2 over 2 or 1. Good so far? So I got the rise and the run. Just count the... and on your screen it'll be better. You can see the lines better, you know. They're not showing up on the overhead very good. But it's up 2 over 2. So, yeah. So there we go. So that's the slope is 1. Now, what's the b? How do I find the b? Yeah, the b, do you know what the b is? The b is, this is where it hits the y-axis. Yeah, the y-intercept, in other words. It's where it hits the y-axis. Where does this line hit the y-axis? Right there. What's that? Up 4, huh? So the b is 4. Hits it. Now, even though it's well, yeah, but it's an open dot. Whatever. It gets infinitesimally close there. That's just the fact that it's less than 0. It doesn't quite make it to the middle, but it gets infinitesimally close to hitting at a height of 4. So let's put in what we know. So this equation is, what is it? X plus 4. Makes sense so far? This is the y out here. I don't need to put in the y. The y is in the front. Good so far on that one? See how I found the slope, rise over run, and then I found the b where it hits the y-axis. All right, can you guys do this one, which is this piece? I gave you a second. Find that one. Same thing, y equals mx plus b, right? Mx plus b. What's the slope? It's 1 again. Can you see the slope? It's, you know, you can go anywhere you want, but like if it goes from 0, 0 to 2, 2, that's up 2 over 2 again. Up 2 over 2. 2 over 2, 1. Slope is 1. What's the b? 0. It hits the y-axis at 0. Right? It hits the y-axis right there at a height of 0. So that's just y equals x. So this one's just x. We're done. Does that make sense? How to work those backwards? So some semesters I put that on the exam. Some I don't. It's whether I'm in kind of a bad mood or a good mood. I'm just kidding. I don't even remember if this is on this one or not. But about half the time it's on the exam. When I'm I consider that one of the harder, definitely one of the harder problems. About half the time it's on the exam. So it's good that I don't exactly remember. I can be an honest teacher, prepare you for everything, and then I'll be surprised with you come next week. What's there and what's not. I mean, I don't know in particular. All right, there we go. Questions on that? Is that okay? Working that backwards? There's a couple of those. But it's really just a plug-in, I think. Yeah, but you got to read the words to kind of carefully to get all that. Let's see. The wind chill factor on a certain planet is given by the formula on the right, where V is the wind speed in meters per second, T is the air temp. Okay. So W is the wind, the wind chill factor. Okay. Find the wind chill for an air temp of 5 degrees, wind speed 0.75. Okay. All right, so do you see what we do? Basically, this is a piecewise function. It says, hey, if your velocity is between 0 and 1.77, plug into that. If your velocity is between 1.77 and 20, then plug into that awful thing. And if your velocity is greater than 20, then plug into that thing. That's what it's saying, right? That's what how a piecewise function talks to us, right? Okay, so what is our velocity here on part A? Yeah, my velocity is right here. Wind speed, velocity, right? It says up here in the words, V is wind speed. So this is V. V is 0.75. What's that? Well, that's between, that's between 0 and 1.77, isn't it? 0.75 cents is between nothing and $1.77, right? So I'm going to plug into T. T. What's T? T is the air temp. Yeah, always look at the words, right? T is the air temp, 5 degrees. So what's the answer? 5 degrees. right? See how I followed the yellow brick road there? All right, I just did what it said. It said, hey, if you got a V that's between 0 and 1.77, the air temp is just the air temp. In other words, the wind's not blowing hard enough to make any difference. It's just the normal temperature. It's just 5 degrees. Good so far? Now that's part A. That was nice, but I don't think part B and C are as user-friendly. Let's see. I don't remember. There's another plug-in. So now it says, find the wind chill. Air temp's 5. Wind speed's 11. So now the wind speed is 11. So 11 is in this zone, huh? 11 is between, one. So V is 11 is here. So that means you got to plug in the T there, the T which is 5, and the V. You got to plug into those two spots the 11, right? And just crank it out in your calculator. So that's just that one. And then the last part, yes, the last one. I guess they're just gonna. Well, are they? I think they asked like a trick question on C, if I remember right. No? Okay, anyway, so I don't want to work that out. I don't. Okay, so here we go. We're in 2.5, transforming graphs. So these are good. So this, now I talked too much, but it's good that we're ready to go. I did a bunch of this kind of yesterday, right? I kind of got you ready to go. So we talked about how do you graph. So remember, on the exam we take Wednesday, Thursday, it's not going to be multiple choice like this. Instead, it's going to be other things, but it's good practice. So let's just look at that function. Basically, we're talking about y equals x squared, right? Y equals x squared is the U shape that sits at the origin and goes up. Now this one's going down, and it's been moved up and is headed down. So what makes that happen? What makes it go up and head down like that? Yeah, well, let me start. So let me remind you again of what I said yesterday. When you take the x squared equation and you do something like plus whatever 7 or whatever out here, what is that going to do? What is x squared? What is that plus 7 going to do out there? Is that going to move the graph up 7? Yes, it actually will. Why? Because this is a y effector. Did you catch what I was saying yesterday about that? Meaning, now what would be helpful if I showed an x effector? This 7 would be would have an x effect. That 7 would. See the difference? If you're in there, in X's little world, like they always say, walk a mile in my shoes. If you're in X's little world, living in his little world with him, then you're an X thing. Which means on the graph you're going to have a right-left kind of effect, because the x-axis goes right and left. Whereas if you're removed, you're not in X's shoes, you're out to the right, or left, or wherever, you're not in whatever he's doing, being squared, being rooted, being absolute value, whatever, right? Those 6 basic functions we looked at. If you're not in his little world, then you're not an X thing, you're a Y thing, which means you're going to have an up or down effect. Does that make sense? So a plus 7 out there would be up 7. So let me just, I think it'd be best if I just wrote out the examples for you. I think that'd be most helpful and clear for you. So let me just say this. If we had x squared plus 7, that would be up 7. Is that on the screen? No. So I got to put it over here, I guess. That would be, well, here, let me just move it down here. Okay, so if we had x squared plus 7, that would be an up 7. If we had x squared minus 7, of course, that would be moving the graph down 7. If we had x plus 7 squared, what would that do? I'm giving you a trick question. Left 7. Yeah, so that's the other part I want to tell you. X has an opposite direction effect. So first time, that's an X thing because he's in X's world. So it's going to be right or left. And normally we think plus 7 is right. X always does the opposite. Y does normal. X does the opposite of what you would think. X is always the opposite direction. So then what would x minus 7 squared be? That'd be right 7, huh? Does that make sense then? See how it's a y or an x, and x always does opposite, y does normal. Okay. So now, let's write some more of these. What do negative signs do? Well, it depends where it's at. So I can come up here and go, negative x squared, what's that going to do? Is that negative, which is really a negative 1, right? Is that an x thing or a y thing? Ask yourself, is it in x's little world? No, in x's little world would be like this. That'd be an x, which would do nothing because that negative is squared and positive. But still, it's an x. This is a y kind of thing on this one, huh? So that's gonna turn the graph over. It's gonna flip it. It's gonna flip it down. So negative signs and a y have a vertical flip. Now this negative is on x. So what would that do? That would flip the u shape sideways, which does nothing. And sure enough, you know negative in the parentheses squared does nothing. So we have agreement. Graphical movements and equation actions, they all agree. So that's just a sideways flip, so that would do nothing. All right, so with all that together, what has been done to this graph? He's been moved up 7 and flipped, hasn't he? So which one of these is a move up 7 and flip? That one, huh? That's move up 7 and the negative in front of the x squared flips it. Is that good on that? All right. Okay, so let me give you a second to think about which one that might be. What's been done, normally the V goes up, so it's been turned upside down, and it's been moved to the left 1 unit. That one, huh? Everybody see that? Because that negative sign flips it down, and that x plus 1 actually moves left, because x does the opposite. Everybody good there? Is that making sense? All right. All right, let's try that one, guys. And gals, try that one. Y equals square root of x, shifted to the right 5 units. What would they want you to write the equation? Like, in other words, is it y equals square root, x plus 5 minus 5, in the root, out of the root, whatever. You figure out what's going to become. Is it maybe like this, or like this, or like this, or like this, Basically, those are your 4 options, right? The 5's either inside the root or it's not. It's either plus or it's minus, huh? So what goes right 5 units? That one, huh? Everybody good with that? Because it's got to be in the root. It's not this one. What's wrong with the top one? That'd be a y. Because that minus 5, this would be down 5. Because that 5 is not in x's little world, right? He's not in the root. So there's a y effector. He's going to be up, down. He's going to be down 5. This one is right 5. Because he's in x's world and he's opposite. So that's what they want. All right. So take that thing and reflect it about the y-axis. Let me let you think about that for a minute. Well, let me give you one important hint. Here's the y-axis, right? If you have a graph and you reflect it, that means you grab the y-axis like it's a, what's it called, a barbecue where you turn the thing? Rotisserie. It's like the y-axis is a rotisserie. You're grabbing the y-axis and you're turning the graph. So in other words, it's really a right and left flip. Do you realize that? It's a right left kind of flip. It's not an up-down flip, in other words. It's a sideways flip. That's what I'm trying to communicate. It's a sideways, right-left kind of flip. It's not an up-down. But when you first read it, you go, y-axis, that's up-down. Well, no. When you grab the y-axis and you turn it, that's a right-left kind of flip. So we're actually talking about an x effect, aren't we? Does that make sense? So you got to watch out. Got to be a little careful on that. So they're trying to trick you. All right. So now you know. Make that thing do an x kind of flip. So you got to put a negative sign somewhere, right? A negative sign's got to multiply something. So where's it going to go? Right on the x, in x's little world. But of course that is the same as this, because if you cube a negative, it doesn't matter if it's in or out, huh? So both those are right, aren't they? Yeah, I'll just say or. Either one of those, that's supposed to say or. Either one of those is right. They're both correct. They're both right. So either one of those. That make sense? That's an x flip, a negative on x. All right. What if they'd wanted it flipped down? How would you do like a y negative? That would be you put a negative through the whole right side. Because y equals the whole right side, doesn't it? See what I'm saying? So to make a flip down, you would run a negative through the entire thing, but that's not. This is our answer over here, because we need a sideways flip. But if they had said, flip it about the x-axis, flip it, vertically, this would have been our answer. Good? All right. This one's going to be a little tricky. All right. So horizontally stretched. So that we're talking about grabbing the graph, grabbing it's a square root graph, right? Square root of x, and going, pulling it to the right, stretching it 7 times as big as it had been, right? Stretching it to the right 7 times as big. Now, what does stretches and compressions? That's different than movement, right? That's different than movement. So we're talking about stretching the graph. It's still anchored at 0, 0. We're not moving it. So let me write out some examples. So if you have, again, square root of x plus 7, that'd be up 7. Square root of x minus 7 would be down 7. These are all y equals square root of, and then put the plus 7 in the parentheses. What is that? Left 7. And put the minus 7 in there. That's right 7. Okay, those are all movements, aren't they? These are all move the graph. That's different than stretch it. So now, how do we stretch it? Well, if we put the 7 in the front like that, you tell me, that 7 positioned in the front, is that an x kind of thing or a y kind of thing? Is it in x's little world? Is it in there? No. So that's a y. That's a vertical thing. So that would be vertical stretch times 7, right? That'd pull it up 7 times as tall, right? If you put 1/7 in the front, that would be a vertical compression, right? Times 1/7. That'd be just pushing it down vertically, okay? Now, what if you put the 7 in there? Now that's an x compression, isn't it? Because now he's in x's little world. What is that? That's 7 in there. What's that going to do? Is that going to... Here comes the trick question. Are you feeling sharp this morning? This is probably the trickiest question of the day. Think about everything I've said to you. That's 7. First off, is he x? That's not the trickiest question. Is he in x? Yes. Because he's in x's little world. Okay. He's multiplying by 7. X. You ready? Does that mean it's going to grab the graph and do what I'm showing you? Pull it to the right 7 times as, or is it actually going to compress it? Why would it compress it when it's multiplied? I thought multiply was bigger. Didn't multiply over here, make it stretch it, and then the dividing, the fraction made it compress. Why would that compress? You're right, it compresses. Why would that compress it, not stretch? Because x does the opposite. Always. Always. You got to always remember that. X always does the opposite of what you would think. So normally, yeah, times 7, that's a stretch. Not for x, though. So for x, that's a not vertical. That's a sideways, horizontal compression. Really, times 1/7, huh? It's going to take that thing and accordion it, right? Squeeze it down. Whereas, what if we had the root of 1/7 x? What would that do? That would stretch it now, sideways 7 times. That's a horizontal stretch times 7. That's what we're looking for. That was the original question, right? Horizontal stretch. That's our answer right there. And you can make that's the same thing as x over 7 inside the root. I'll say or x over. I think math excel will take it either way. Same thing, right? 1/7 times x or x over 7. Same thing inside the root is going to actually be a horizontal stretch. X does the opposite. Do you like these? These are tricky. It's like playing a fun little game, right? You keeping up? We good? Thea, you're having fun. I can tell, huh? Number 11. All right, so we're going to start with y equals square root of x. All right, you ready? Here we go. Part 1. Down 7. Go ahead. Do something to that equation to make it go down 7. All right? Down 7. The minus 7 has to be outside the root, not inside. Right? Can't have it in the root because it's got to be a y, up-down thing. If you're in the root, that'd be a side. If you wrote this, that would be a sideways thing. And that's not right because if it's in x, if it's in x's little world, it's a sideways thing. It's an x thing. If it's out, it's a y thing. All right, next step. Now they want us to build. That we're not going back to the start. We're continue with this now and take the next step. Reflect about the x-axis. So reflect that. Now remember what that means. They think about a little axis. Here's the x-axis. If you grab the x-axis like a rotisserie, it's going to be a vertical flip, isn't it? That's tricky. It's a vertical. So that really means a vertical flip. Okay, so vertically flip that thing. Go ahead.
I have a
Question.
question. It's not the opposite for minus 7 or down 7?
No, y is normal. X is opposite. Yeah, good question. Everybody got that? Why was this not opposite? Because y is never opposite. Y is normal. That's a y. It's only x that does opposite. All right, so vertical flip. So if you grab the x-axis and you flip this way, it's vertical. How do you take that? You run a negative through the entire thing. Look what I did. I took -1, distribute it through the whole thing. The whole thing, right? It's a little off the screen there. Not just the x part. Does everybody see that? Not just the x. Why? Because the y equals the whole thing, not just the x part. There we go. Right? Everybody see that? Because y equals the whole right side. So if you're going to have a y negative thing, you do the whole right side, not just the front part. Everybody see that? That has a vertical. If we are talking y, even though this said x-axis, we saw over here that x-axis flip is a y flip, really. It's a vertical flip. So negative through the whole side. Now, part 3, keep building. Take this now and do the last step. Reflect about the y-axis. And you know, y-axis, that means sideways. That means a sideways flip. In other words, an x flip, huh? All right, can you do that? Where's the negative go? Just on the x, right there. Oops, I'm off the screen a little bit. Darn that projector. I gotta keep doing this over and over again. So I put it right in there with x. See the difference? Only thing that changes is just that little bitty x in his little world becomes a negative x. Just the x. So you see the difference? Whenever we do something on x, we just go into his little world, inside the root, inside the absolute value, inside the second power, whatever is on him, right? Into his little world. But when we do y, we do the whole right side, because y equals the whole right side. Doesn't it? Does that make sense on that? You might want to, can you have a negative inside of a root like that? Yeah, but see, you would have to just plug in x's that are negative. I can plug in x -1, then negative -1 would work. So it's possible. It just means x is going to go the other way. All right, so let's. All right, try that one. So go through those 3 parts. First, reflect it about the x, shift it down 2, and do that last part there. I'll run through the roll. This week is the last week to drop any class at City College, right? I want to let you know, if this is not for you, drop by Friday, and you get nothing on your transcript. It's like you were never here. But starting Monday, you're going to get something on your transcript, right? Then you have up to the end of the 9th week to drop, but you'll get a W. You'll get a W on your transcript if you drop after this week. And then up to the 9th week is, after that you're in for a grade for sure. Does everybody know how it works? That's for any of your classes. So if you want out, get out this week from any of your classes. There'll be nothing in your transcript. The next 6 weeks, you can drop and get a W. Roberto.
If you would write my schedule real quick.
Yeah, sure. You need a pen?
You can write it on the.
Okay, yeah.
Just real quick.
What you got?
So we have Monday 3 to 5.
Okay.
And then we have, Wednesday, 1 to 3. And then lastly, Thursday, 1 to 2. So from now on until further notice, that's supposed to be the session time.
All right, Roberto over at LI 134, right? Tutoring Center. So he will show you the advantage. Somebody came out and asked me just today, what's the advantage of ETC versus there's 3 kinds of tutoring on campus. So there's, in the math building, we have like some math tutoring going on. You can find the schedule. It's outside my office. It's outside most of the teachers' offices. You'll see a little schedule, right? We have tutoring going on in the math building. That's good tutoring. There's usually a math teacher there. Not always, but I think most of the sessions we have a math teacher there and a tutor or two, and so that's helpful. We have general tutoring at the tutoring center in the library. So that first one was in the math building. There's a schedule. Look at any of the math teachers' doors outside my office or any of them. And then in the math building, in the library, LI 134, we have general tutoring 9 to 5. There's always a tutor available. But they're going to probably show you a different method. Maybe. It's random. You might get somebody good, you might not. Then there's Roberto. That'd be the best option because he's going to show you exactly like you're getting in here. He's going to have my practice exams. He's going to be more dialed in. And there went my time. Well, that was good use of time anyway. All right. I don't do roll anymore. All right. We will stop there. So all that's due then is 2-4. 2-4 is due on Thursday. 2-5 will be due on Monday. Finish that problem due on Monday. Have a good day, guys. Oh, if you want a calculator, you want to rent a calculator, tomorrow's the day, Thursday at 4 o'clock. It's going to be hard to get it, though. First come, first serve. You need to bring your FCC ID card, proof of enrollment, like WebAdvisor screenshot, your student email address, and a phone number. In the Science Building, room 1, 4 p.m. Be there an hour early for the line. Yeah, see you, Tim.